Well, good morning. Today we're going to be looking at the Sky Top Power SP300 5H. So I'm just going to pull this sucker apart. We're going to have a look inside. We're going to put a few different loads onto it, namely a 100-watt LED and when you kind of start with power supply for the things right here, is information about power being drawn. Alright. So we're just gonna have a quick look. So first up, when I first had this apart, I took the fan and I reversed its orientation in the case. I didn't find that when it was blowing air out this way that it was pulling a lot of air from all these components. So this way it's blowing air in, and the vents on the case will allow the air out of the case. So I think that's a better way to have it set up. But again, you can leave it stock if you want. So here you've got your power supply components over here. You got two big caps. Now the interesting thing is they actually have two bridge rectifiers inside. This is the main one for power for the output of the device, and then you've got another one down in here. If you can see my finger poking it right there. So yeah, that's that. You've got power from the wall coming in, and it actually goes right to the front switch. So when you turn the power off on this, there is no 120 volts AC going to the main large power supply, which is a good feature. Over here you've got what else you got? You got your your main computer chip that regulates the power output. You've got a bunch of I can't remember what they're called. I'll just read the chip name off for you. If that helps. No, maybe I'll just put it in post. Anyway, yeah, that's the inside. That's the back side. Not too much going on. Oh yeah, fun fact: potentiometers. As you know, with a potentiometer, sometimes the rubbing portion wears out, and you lose the ability to accurately control your voltage. So on here, they just treat it as a variable resistor, and they connect the center wiper pin to the maximum treble pin. So instead of the resistance going to infinity, it goes to the maximum potentiometer value. Unfortunately, they didn't do that on all of the pots. Like you'll see on the fine adjustment, they've got that done here with those two pins, and then there's the pots here. But the large adjustments, they've actually got all three separated, which is bizarre. And the same with the trimmer pots here. So they've gotten smart and connected them and just treated them as variable, well, a single variable resistor as opposed to opposed variable resistors. So yeah, it was kind of interesting. Here you've got your metal oxide varistors, and that's to stop the shoot through of high voltages from static electricity in your hands to whatever. So good to have those. Good to see them there, at least. I wasn't expecting too much from this power supply. Another fun thought is, interesting thought is the reduction of the capacitors that they have here. And one way I like this, in this case only, because when you're lowering the voltage on the power supply, so you're going from, let's say, 30 volts to 10 volts, there's a parasitic resistor that is shorting or connecting these resistors to ground, so that allows you to drop the voltage faster. I guess you could have larger capacitors and a larger parasitic resistor, but it's going to waste more power, just so that you can decrease the voltage in a quick fashion. Another interesting thought is these metal oxide varistors. There are spots for them in the board over there, or right here, and they decided to put them right on the back plate there, so that's kind of interesting. Another annoying thing about this is it always is putting out 80 milliamps of kind of trickle current, even when you set the current potentiometers to 0, and that can be a problem if you're testing out an individual LED to see how bright it is versus how much current and power it consumes. Because a lot of LEDs are maximum output is 20 milliamps, and that said you should only go up to maybe 15 milliamps. So if you tune the voltage carefully, it will give you less current, but always have your fluke meter connected to verify current output and voltage output, because the LCDs on the front are not representative of what's really happening. And I mean, I like Fluke. I've used them a lot, but lots of multimeters will give you good accurate readings besides Fluke. Anyway, I'm gonna pause and plug her in, and yeah, we're gonna do some loads. Alright, so first up we're going to test out this 100 watt LED. I'm only going to probably drive it to 60 watts with this supply because it can only get to 30 volts maximum on the output. So yeah, this is nice. This particular test is, you can see how crappily the LED parts are made. So you'll actually see here in a moment that some LEDs will light up before others do, and those will probably be the ones that die first because they're going to be putting out higher power than the rest of them. Although if the thermal conductivity, i.e. the heatsink, is good, shouldn't be too bad. Alright, so I'm just going to increase the voltage to probably about 22, and you're going to start to see the LED will start to light up. So there it is. So now you can see some LEDs are quite well lit, others are not. And as we go brighter still, we're going to see it start to put out, you know, a stupid amount of brightness. And you can hear the... So now we've got our limit. So the current is set to 0, and we're still getting 72 milliamps of shoot through, even though both of our current potentiometers, the fine adjustment and the coarse adjustment, are set to 0. Alright, so next up we've got a nice little air compressor. Opposed piston, and this one actually has wrist pins. So for $10 from Canadian, what is it? Canadian junk store. There we go. So that's my favorite thing to do, is just finding the absolute minimum power I can put in before it'll start. So we're drawing 1.1 amps at 1 volts just to get this motor to start to turn. And I'm just going to go up to pretty high speed just to see how much current we can draw. So yeah, drawing about 5 amps at 12 volts with under no load. So as I put pressure on there, it will reach this supply's maximum output. Also wanted to note, yeah, the fan starts up with current draw. So as I draw more current, it'll turn on the fan and continue cooling itself as it goes. Ain't that just great? Yeah, not sealing too well. Anyway, I hope this video helped out. Whether or not you want to get this supply, if it's right for you. It's not very powerful. I mean, it should be able to do 30 times 5 worth of watts DC. So, yeah, 30 times 5. Yeah, 150 watts. So that's if you have a load that's 30 volts and consumes 30 watts. So if you had like a bunch of, like a couple of these LEDs, you could get this thing to its 150 watt rating. But again, it will cap out at 5 amps at between 0 and 30 volts, or cap out at 30 volts and things. So that was the point of these two loads, so you can see both the voltage and current getting maxed out at their respective currents and voltages for what their loads were. So this is high current load, the LED was a high voltage load. So yeah, so to conclude my review, I really like this supply. It's going to come in handy for all kinds of projects, just to be able to clip on and go and see if it works and not worry about frying the supply, at least so far.